So we're going to talk about the circulatory system today. Circulatory system. Circulatory system is the system of flow of body fluid in the body. So body fluid is blood and tissue fluid. So circulatory system contains two systems. That is cardiovascular system and lymphatic system. Let's go to the note and then I will come back in the presentation mode. So here, circulatory system has cardiovascular system. Cardiovascular system contains cardio means heart and blood vessel means vascular means blood vessels plus lymphatic system. So two system, cardiovascular system and lymphatic system together is called circulatory system. Lymphatic system contains several organs like lymphatic vessels, lymph nodes, lymphatic tissue, and lymphatic organs. And we're going to talk about lymphatic system in two lectures later. Okay. So today in the cardiovascular system, we will go over an overview of the circulatory system, and we will focus today on blood. In blood, we will talk about composition of blood, what are the components of blood, which is liquid and cell part. Then the most important cell in the blood is red blood cells or RBC. And in RBC, we're going to talk about detail about RBC, their structure, their function, and also the red blood cell plasma membrane contains antigens. It may be protein molecule or sugar molecule, and that determines your blood type, whether you are A, B, positive, negative, AB or negative. Okay. So we're going to talk about blood typing too. You're going to understand and learn what is the basics of typing your blood. And then we will see some blood disorders. What are the blood disorders which is common in associated with bloods like anemia, polycythemia, uh, and other blood cancers. The function of blood is to stop bleeding too. And it is the platelets in blood which does that function. So in detail, we will talk about platelets role in blood clotting. Blood clotting has two pathways, intrinsic and extrinsic pathway. Intrinsic pathway is a little bit longer pathway, and we will talk about both intrinsic and extrinsic pathway of blood clotting. Okay. So component of the circulatory system includes cardiovascular and lymphatic system, as I said earlier. In the cardiovascular system means cardio means heart. Heart pumps blood through cardiovascular system. And vascular means blood vessels. And blood vessels carry blood from heart to cells and back. And this blood vessel carries arteries, arterioles, capillaries, veins, venules, and veins. Okay. So we have heart. And then from the heart, large blood vessels exit that branches off and spread all over the body, provide oxygen, nutrition, liquid to the tissue. And then those branching ultimately are so thin, the wall of those blood vessels, and tiny. We call them capillaries. Those capillaries again then join. And once they join, they form the smaller venules and then veins. And those veins again return back to the heart with blood and tissue fluid. Are you following me? So cardiovascular system is a closed chamber. Okay. So blood vessels are arteries. Arteries and veins. So arteries carry blood away from the heart. Arteries carry blood away from the heart. Whereas veins brings blood to the heart. Okay. On the other hand, lymphatic system picks up excess fluid filtered out in capillary beds and returns it to veins. So as I said earlier, when heart gives off large arteries, branching of those arteries forms the tiny capillaries. And that's the location where there is exchange of gases, exchange of nutrients, exchange of waste product, exchange of water. And then it goes to outside the blood vessel, inside the tissue, around the tissue. And that is called tissue fluid. Some of the tissue fluid, some of the nutrients, some of the electrolytes, some of the solid particles, some of the waste products return back to the capillaries and enters the vein. But most of them no, don't. And the fluid and the particles which are not returning back to the veins is carried by and picked up by lymphatic vessels and return into the veins. Particularly, they bring back from all over the body and drain into the vein in the neck region. Okay. Its lymph nodes are parts of immune system. So on the way of lymphatic vessel, there are lymph nodes and they carry white blood cells. They fight infection if there is any microorganism, and that is the part of the immune system. Okay. So what is the difference between interstitial fluid and lymph? What is the difference between interstitial fluid? Interstitial fluid is the fluid in the tissue. And when that fluid enters the lymphatic vessels, then it becomes lymph. Are you following me? So if the same tissue fluid enters into the veins, then we call them plasma. Okay. So this is circulatory systems overview. Function of the circulatory system. Circulatory system carry blood cells, carry water, carry plasma proteins, and carry some solid particles in the blood. And that's why it plays a role in transportation of respiratory gases. Particularly, respiratory gases are oxygen and carbon dioxide. Deliver nutrients and hormones to the tissue. So as you know, any endocrine glands produce hormone and they do not act locally. They needs to go far away. And that then act in other organs. So this is the cardiovascular system. This is the blood which carry them. It also remove the waste product from your body. So let's see, when you metabolize uh, the amino acid and you produce urea, creatinine, uric acid, those waste product needs to be cleared from your body. And this blood then carry to the kidney excrete them. That's the example. Blood also maintain your body temperature, because when you have hot weather, your blood vessel dilates and brings your core blood to the skin surface and you lose the heat by convection. Blood also helps in clotting. When you have a cut, this is blood which heals the cut. And most importantly, blood contains white blood cells which fight infection. That's why they play a role in immune function. Blood also carry a lot of electrolytes like sodium, potassium, calcium, magnesium, zinc, all the macromolecules. And those electrolytes has big role in our body, as you know, in different physiology. Composition of bloods. Blood composition, blood, if you see the sample, if you take a sample of blood, so from the vein, you take a blood because veins are superficial. When you see a blood, blood is very red colored fluid. And if you put blood in test tube in the centrifuge and centrifuge it, then it settles down into two layers. The heavier layer, which is formed of or which contains blood cells, are called the formed elements. Okay, so formed elements, most of the formed elements, bottom part, the red part, is the packet of red blood cells. So you see in the formed element, almost 99% of the formed elements are red blood cells. And then in the middle, you have some white layer, buffy coat. That buffy coat contains white blood cells and platelets. On top of these formed elements, you have straw color plasma, liquid portion of the blood, and that is blood plasma. So blood plasma is around 55% of total blood, and formed element is around 55% of total blood. The the formed elements, you see here red blood cell portion of the formed elements. This red blood cell portion formed part of the formed elements is called hematocrit. So hematocrit. The percentage of red blood cells in centrifuge blood is hematocrit, which is around 45, 46%. Okay. Now, if you take a blood sample and then spray it on a blood slide and make a smear, you're going to see blood cells. Okay. So you see these are red blood cells. Red blood cell is also called erythrocytes because they have erythrocyte red color. They have no nuclei. We're going to go over in detail about them. And then there is some white blood cells. See here? And some fragments of blood are the platelets. Total blood volume is about 5 liter, around 5.25 liter. And the plasma is the liquid portion of blood, which is a straw color, which contains water and dissolved solids in the plasma. So solid particles of the plasma contains ions. The examples of ions are calcium ion, potassium ion, magnesium ion, chloride ion, bicarbonate ions. Those are the ions, hydrogen ions. And then metabolites. Metabolites means when you have eaten sugar, then glucose, fructose, galactose, amino acids, the some pyruvic acid, then other molecules, NADPS, several molecules, some hormones, and most importantly, plasma protein and antibodies. So out of 7 to 8% of the solid particles, plasma proteins are almost 7%. And 1% is all other solid particles. Plasma proteins maintain our osmotic pressure of blood. Do you remember osmosis lab? It is solid particle in a solution which create osmotic pressure. And in our plasma, in our blood, it is plasma protein which plays a major role of osmotic pressure, not the blood cells. Okay. So again here, red blood cell RBC comprise most of the formed elements, which is around 36 to 46% in female and 41 to 53% in male. And that is called hematocrit. So hematocrit is percentage of red blood cell in centrifuge blood sample. Our textbook and a lot of several other, if you Google or anywhere, they will say formed elements percentage is called hematocrit, which is completely wrong. it is only percentage of red blood cells in the centrifuge blood, which is hematocrit. Okay. Let's talk about plasma protein. Plasma protein is 7 to 9% of plasma, and the rest is in solid, the solid portion of the blood. Apart from the blood cells, the rest is the electrolytes, which is 1% around. So plasma protein is important because it maintains osmotic pressure of our blood. And there are three types of plasma protein: albumin, globulins, fibrinogen. Albumin accounts for 60 to 80% of those 7 to 9%. That means most abundant plasma protein is albumin. Albumin creates colloid osmotic pressure that allows H2O from interstitial fluid into capillaries to maintain blood volume and pressure. That means if inside your blood vessel, particularly capillaries, if you have enough plasma protein, that means your tissue fluid will move into the plasma and maintain your plasma volume. Are you following me? Globulins, on the other hand, carry lipid. These globulins binds with the lipid and hormone and carry them. That's why sometimes they are precursor of the hormone too. There is another special globulin that is called gamma globulins, like beta gamma globulins, and they are antibodies. Okay. Fibrinogen is another protein particles found in as plasma proteins, and they serve as clotting factor. We will talk about fibrinogen at the end of this lecture. So what does fibrinogen do? Fibrinogen converted to fibrin with the action of thromboplastin, and that then uh, make the mace work of clot. When we when blood clots and you take out the clot, whatever is left is the serum. Okay. Okay. So let's see, serum is you have a blood, you take out formed element, and then you have plasma. You take out all the clotting factor and fibrinogen. Whatever is left is serum. Okay. Serum is used a lot to diagnose antibodies against microorganism infection in our body. So when you go to doctor and you have a fever for 2 weeks, doctor will take blood, find out the serum, and find out which antibodies you have in your blood. So I want to connect some clinical correlation here in albumin. I'm gonna pick some of you. Say if I have more plasma protein in my blood, that means my osmotic pressure will increase or decrease.
It will increase.
It will increase. If an osmotic pressure of plasma increase, the water will move from tissue into the blood vessels or from blood vessel to tissue.
Tissue to blood vessels.
Tissue to blood vessel, because water moves towards the higher concentration of solid particles. Now let me tell you one thing. If you have kidney failure, have you seen patient with kidney failure or malnutrition kids? If you have kidney failure, what happens? You will lose protein into your urine. That means your plasma will have less amount of albumin. If you have less amount of albumin in your blood vessels, osmotic pressure drops. Clear? If osmotic pressure drops, then what will happen? Water will move from where to where?
Blood to the tissue?
Blood to the tissue. And if the tissue, if there is more blood, what will that do? That will cause accumulation, addition of water into your tissue, and that will swell up, and that cause swelling of the tissue. And what is the another terminology for swelling of the tissue? That's
Edema.
called
Edema.
edema. That's called Edema. Have you seen kidney failure patient with edema?
Yep.
Yep. You will see their face swelling, their leg swelling, their hand, body swelling, particularly dependent edema in the lower parts of the body. That's why this happens. Okay. Okay, now formed elements. Formed elements are the cellular component of the blood. Okay. And there are three major types of formed elements: red blood cell or erythrocytes, white blood cells. Here you see, these all are white blood cells. This one, basophil, eosinophil, neutrophil, lymphocyte, monocytes, and then fragment of small fragments of these cells are platelets. Let's talk about erythrocytes. Formed elements are erythrocyte, RBC, and leukocyte. RBC are also called red blood corpuscles or red blood cells or erythrocytes. They are a circular structure with biconcave discs. So this is like a donut without hole. So if you have a donut and you fill up the hole, what happens? That's how red blood cells are. And the plasma membrane of red blood cell are so flexible that it can squeeze through the smallest capillaries. Okay, that shape, that's why we call RBCs are flattened biconcave discs. Their shape provide increased surface area for diffusion. So if you have a balloon and you press in the center, then it becomes biconcave disc, and that's how it is increasing the surface area of red blood cell. You are putting more surface area of red blood cell in a small area. So like if you want to keep one balloon, one balloon is taking this space, and if you squeeze in the center, then you can keep the same balloon in a smaller area. That's why you are increasing the surface area of the red blood cell so that you can exchange more gases. The Sometimes the red blood cell doesn't even look like a cell. They lack nuclei and mitochondria, so they have not pretty much organelles. Their cells like empty. So what are filled with then? Last time we talked, our muscle cells are completely filled with myofibrils. Red blood cell is totally filled with the main component of red blood cell, that is hemoglobin. That's why each RBC contains 280 million hemoglobin molecules. And these hemoglobin molecules carry, these hemoglobin molecules carry oxygen, and we're going to talk about them. Okay. About 300 billion RBC are produced each day. Because they have no mitochondria, they don't replace themselves easily, so they die in 120 days. The lifespan of the red blood cell is 120 days. That's why every second our bone marrow is making red blood cell. Usually red bone marrow in flat bones, irregular bones, epiphysis of long bones makes the red bone marrow. So what stimulates bone marrow formation? Okay, let's see here. The hormone erythropoietin, erythropoietin, which is also called EPO, EPO from kidney, stimulates bone marrow to move. If you have to sing, guys, then turn off your mic. I appreciate singing. So the erythropoietin hormone from kidney stimulates our red bone marrow to produce red blood cells. And it is stimulated by lack of oxygen. So when you climb high mountains and there is less oxygen pressure, your kidney will produce more EPO, and then your red marrow will produce more red blood cells. Okay.
So that's why like athletes will go to higher elevations to train, right?
Yes,
To
and
get the
that,
like
yeah, yeah.
more production, and then it stays in your, how long does it stay
The
in
erythropoietin, this is not long time. Once you descend and uh, if you don't go back again, or you don't do exercise, or you don't challenge your body with less oxygen, they will normalize again. And sometimes this is misused too, erythropoietin, like marathon runners.
Oh, like that's blood doping, right?
Blood doping is just packed red blood cell they put in their blood. Sometimes what they do, they just take erythropoietin, and like week or days before the marathon, and they put erythropoietin, make a lot of red blood cells, so you have now more carrying capacity. Blood doping is like they take just pure red blood cells extra. Yeah. Okay, so that is the red blood cell. The main component of the red blood cell is hemoglobin. So here is the structure of the hemoglobin. Let me show you. So hemoglobin, how many hemoglobin we have? Here is red blood cell, and we are magnifying one hemoglobin. So how many hemoglobin we have in each red blood cell?
280 million.
300 million.
Oh.
So here, one hemoglobin is hemoglobin. You see here name, hemo means, hem means pigment. Globin means protein particle. Okay. So hemoglobin is made of heme and globin particles. So you can see here the disc shaped globin here, the circle, not globin, disc shaped heme here, and the chain of amino acid, the globin. There are 4 chain of globin. Here, alpha 1 chain, alpha 2 chain, beta 1, and beta 2 chain. And in the center of this globin protein, there is heme group. Inside the heme group, you have iron molecule. It is iron which is oxidized when it binds with the oxygen. And when it releases to the tissue, then it is reduced. Nothing to do with this hemoglobin. Hemoglobin, the globin portions, the heme portion just helping iron to keep them. Okay. Now, if you have lack of this hemoglobin, then you will have anemia. If you have lack of iron, which is deficiency of nutrition, that is called iron deficiency anemia. US has the iron deficiency anemia is one of the most common anemia in US, because female every month menstruate and you lose the red blood cell, and so you lose hemoglobin and iron, and that's why there is iron deficiency. That's why even developed country like US suffer from a lot of iron deficiency anemia. That's why you have to maintain iron in your dietary supplement, not from the outside, with the green vegetables, a lot of vitamin C. That's how you can maintain it. Okay. Mutation of these alpha chain and then abnormal hemoglobin causing less oxygen carrying capacity is called alpha thalassemia disease. Mutation of beta chain called beta thalassemia. Okay. I have written in my notes. So if you go back, you can see thalassemia, alpha thalassemia, and beta thalassemia. And we talked about anemia. Anemia can be due to several reasons now, you know. It can be due to excessive bleeding and loss of red blood cell. It can be due to abnormal hemoglobin. It can be due to deficiency of iron. It can be due to several other causes. Okay. Now, leukocytes, white blood cells. White blood cells are not red. That's why we call them white. Leuko means white. Contrary to red blood cell, leukocytes have nucleus, mitochondria, and they can squeeze out of the capillaries and can go to tissue to fight infection. And the process by which they exit the blood capillaries is called diapedesis. Leukocytes can be classified into two groups based on whether they have granules in their cytoplasm or no granules in their cytoplasm. So you look at eosinophil and basophils, they have small dots in the cytoplasm and neutrophil. Those are the toxic granules which contains toxic substance enzymes to kill microorganisms. And that's why we call them granular leukocytes, granular white blood cells. These granules help detoxify foreign substance and they release heparin. Okay. This group is eosinophil, basophil, and neutrophil. So how we decide? They all have these toxic granules. So how we determine which one is neutrophil, which one is eosinophil, and basophil? These granules takes different stain, and based on that, they are classified. So if granules takes acidic eosin dye, then we call them, eosin is like red, eosinophils. If they take basic dye, then we call them basophils. And if these toxins takes both dyes, then we call them neutrophils. On the other hand, 2A granulocytes, which is lymphocyte and monocytes, if you look into their cytoplasm, they have no granules. That's why we call them agranular leukocytes. So these lymphocyte and monocytes are agranular leukocytes. Agranular leukocytes are phagocytes, macrophages. These cells get out of the blood vessels or inside the blood vessel and eat up microorganisms. That's why we call them agranular leukocytes. Lymphocytes produce antibodies, okay? And monocytes are the macrophages. Monocytes are macrophages, okay? Lymphocytes and monocyte, how you see? Monocytes are the largest cell, and lymphocytes, pretty much whole cell is packed with nucleus. Monocytes nuclei are like horseshoe structure. Neutrophil nuclei are multi-lobed. Eosinophil nuclei is like dumbbell, not dumbbell, like what do you call? It's like a
Phone.
what?
Headphone. Like a headset.
Yeah, it's a headphone set. Yes, good. It's headphone set like a structure, and basophil is like dumbbell. Okay, so based on that, you can separate these white blood cells. And when we do lab, you're going to do this. You need to understand now. Okay. Platelets, on the other hand, you see here in the diagram, are smallest of formed elements and lack nucleus. They are not even true cells. So when blood cells are formed in the bone marrow, the largest blood cells are the platelets. And later what happens? Once they release from the bone marrow, they are fragmented. And that's why we call them mega, means big karyocytes. So they are from the big karyocytes, but they are fragmented. This is the main part of the mass of blood clot. They plays role in clotting your blood. So when you have a cut and you are bleeding, this is the platelets which clot. So if somebody has platelet abnormalities, those individuals will bleed easily. Like when you are brushing, your mouth will be bleeding. When you have a small uh, scratch, you will start bleeding and it will not stop easily. Even a tiny trauma to your joint can bleed inside the joint. Okay. Platelets also release, the platelets release serotonin to vasoconstrict and reduce blood flow to the clot area. So as well as clot, and at the same time, it also constrict the blood vessel in the area where there is clot, so there is no blood flow increment. Secrete growth factors to maintain integrity of blood vessels. So blood vessels wall, inside blood vessel wall, to make it smooth, healthy, it is platelets which is producing the growth factors. They live only 5 to 9 days. Okay, now the RBC antigen and blood typing. A lot of you know your blood type and a lot of you don't. And when you say your blood type, there is two group of uh, two ways that you group your blood, but you call it all the time one way. Let's see, I say my blood group is B positive. That means I am saying my blood is B. That means my red blood, not white blood. My red blood cell is B and positive. What does that mean? So blood grouping is based on the antigen present on the plasma membrane of red blood cells. Antigen present on RBC surface specify your blood type. And there are two ways. Either you are AB, or O, or you are positive or negative. So first group is called major antigen group is ABO system. Let's talk about first ABO system. ABO system is based on antigen present on your red blood cell, and this antigen is a sugar molecule. Do you remember? Plasma membrane contains protein, sugar, carbohydrate, cholesterol, glycoprotein. It is sugar molecules present on the red blood cell which determines which type you are. Okay, so type A blood has only sugar A antigen type. Type B has only B antigens. Type AB has both A and B antigen. Type O has neither. O means zero, neither A nor B antigens. Are you following me? Now, I want your first class attention here. When you are born with certain blood group, your blood also makes antibodies to protect that antigen from other antigens. Are you following me? So let's see, if I am type B, that means I should protect type B from type A, because if type A comes, that will attack. So type B blood group, if I am type B blood group, that means my plasma will also contain anti-A antibodies. So if by chance anti-A antigen A comes, then I will be protected. Okay, so my blood group will also contains anti-A antibodies. A blood group will contain anti-B antibodies. Type AB, can they contain any antibodies? No, because they have both antigens, so they cannot contain any antibodies. And type O contains both antibodies. So let's see here. That's why you have to give matching blood to the individual. So here you go. This diagram shows People with type A blood make antibodies to type B RBC, but not to type A. So look here. If you are type A and type B, type A, you see antigen on the plasma membrane here? It is A antigen, triangular yellow antigens. Here in type B, you have purple square antigens. Antibodies in type A, what antibodies you have? Against B, you see? What antibodies you have for type B? Against triangular. And if you put cross B with A, what will happen? You see? This is the B antigen, and then anti-A is binding with them. And if you mix match here, A antigen is binding with anti-B antibodies. Okay? And this clumping is called agglutination reaction. So people with type A blood makes antibodies to type B RBCs, but not to type A, type B. Type B blood has antibodies, type B has to A. Okay, type B blood has antibodies to type A RBC, but not to type B. Type AB blood doesn't have antibodies to A or B because type AB contains both antigens. On the other hand, type O blood group has no antigen. That's why it is called zero, type O. And they can contain both type A and B antigens. And if they are incompatible bloods are mixed, they can agglutinate, clump, and cause agglutination and kill the red blood cells. So you see here, if blood types incompatible, recipients antibodies agglutinate donors RBC. So you see here, let's see, this is anti-B. So when we do the blood test, what we carry sample of anti-B antibodies and anti-A antibodies. So if, let's see, I take the slide and put this anti-B antibodies and mix with type A blood, what will happen? Will they agglutinate? No, because type A normally contain these antibodies, so they are compatible. But if I mix with anti-B antibodies with type B blood group, what will happen? It will agglutinate. If I mix anti-A antibodies with A blood group, what will happen? Again, agglutinate. If I mix anti-A antibodies with type B blood group, no agglutination because type B contains that antibodies. Type AB, if I agglutinate with anti-B serum, what will happen? Or antibodies? Because type AB contains type AB contains A antigen. So A antigen and B antigen. So B antigen will bind with anti-B and that will agglutinate. Same thing with the type A and anti-A and type anti-B, AB antigens. So you have to go over this. First, you have to understand antigen and antibodies. Antigens are found on the surface of antibodies. Antigens are found on the surface of red blood cell, whereas antibodies are found in the plasma. Okay. Type O is universal donor because lacks A and B antigens. Recipients antibodies won't agglutinate donors type O RBC. Type AB is universal recipient. So O blood group is called universal donor because they can give to anybody due to these reactions. And type B is, AV is universal recipient because it doesn't make anti-A or anti-B antibodies and won't agglutinate donors, RBC. So you can give to anybody, okay? Another factor is RH factor. And if you have these RH or Rho antigens, which is protein antigen, these are not glucose sugar antigen, they are protein antigen. If you have Rho antigen on your red blood cell, then you are positive. If you have not, then you are negative. This RH antigen is rhesus antigen that was found first in monkey, rhesus monkey. That's why we call them rhesus antigen. And that's why if you have B antigen and this antigen too, then you will call your blood group is B positive. If you have no RH but you have B antigen, that means you are B negative, and so on with all the antigens. Erythroblastosis fetalis is the disease associated with RH factor, and I need to explain in detail about it. So I will go over this again in next class. Okay. Thank you, guys.